Hey everyone! Today we are going to be learning about congruent triangles. Let's acquaint ourselves with some terminology that we'll use. Congruent triangles are triangles that can be translated, rotated, or reflected onto another triangle. Let's write this down now. Another common term that we'll refer to in this chapter is corresponding parts. Corresponding parts of congruent triangles are the parts of the triangles that match. Let's be sure to copy this down as well. Now let's look at the formal definition of congruent triangles, which we will refer to as CPCTC. This definition states, if the corresponding parts of two triangles are congruent, then the two triangles are congruent. And the converse of this statement is true as well. If two triangles are congruent, then the corresponding parts of the two triangles are congruent. So for short, we'll refer to corresponding parts being congruent in congruent triangles as CPCTC. Let's familiarize ourselves with a congruent statement with this first example. Notice that we have two triangles here. We have triangle ABC and triangle FDE. Now, these two triangles each have three sides, of course, and three angles. But what is indicated within the diagram is that segment CB is congruent to segment ED as indicated by the 1 slash through each segment. Likewise, AC to FE, as they're both indicated as congruent in the diagram, and AB is congruent to FD. Also, notice that angle A within the first triangle and angle F within the second triangle have one arc. Remember, this is to indicate that the two angles are congruent to each other. Also, we have angle B indicated by two arcs and angle D indicated by two arcs. Again, that's to tell us that these two angles are congruent to each other. And finally, angle C and angle E are congruent. So, since all 6 parts of our first triangle are congruent to all 6 parts of the second triangle, we may state that triangle ABC is congruent to triangle. Now, what I want us to do is to make sure that we name the next triangle in the correct corresponding order. Again, since angle A is listed first in our first triangle, I want to make sure that I list angle F first. Also, since angle B is listed next in my triangle ABC, I want to make sure that I list the same angle D first. And, well, by default, the last angle we have is E, but let's also make sure that it makes sense. Angle C is indicated by 3 arcs, just like angle E. So we will name angle E next. Again, by this congruent statement, we may conclude all 6 corresponding parts. The corresponding parts are the congruent angles, listed here. Angle A is congruent to angle F. Angle B is congruent to angle D. And angle C is congruent to angle E. Also, we can list the congruent sides. I'll use my congruent symbol here. Again, we can use our diagram to list the corresponding parts, but also within the way our triangles are named, we can list the congruent parts. So let's list that we have segment AB congruent to its corresponding segment. AB are the first two listed in the triangle name. FD are the first two listed in the triangle name. Therefore, we may conclude that FD is the segment that is congruent to segment AB. Also, segment BC within the first triangle, right here, is congruent to segment DE. And finally, we have segment AC, which is congruent to angle FE. So by definition, if we're given that two triangles are congruent to each other, we may conclude all 6 corresponding parts to be congruent. Likewise, if we know all 6 corresponding parts are congruent, we may then conclude that the two triangles are congruent. Let's explore this first example to gain better understanding. This example states, if triangle PQR is congruent to triangle MLN, let's name the congruent angles and sides. Then draw the triangles using arcs and slashes to show the congruent angles and sides. Based on the congruent statement, again, we know that angle P is congruent to angle M, since it's indicated as the first vertex within the first triangle and the first vertex within the second triangle. Remember, we can indicate that in the diagram using arcs. We also know that angle Q is congruent to angle L and indicate that by arcs. And finally, angle R in the first triangle is congruent to angle N in the second triangle. And we can indicate that with arcs. Now, let's name the congruent sides. PQ is our first segment within the first triangle, and ML is the first segment within the second triangle. Therefore, these two sides are congruent, and we can list that using slashes. Therefore, PQ and ML are congruent. Next, QR is our second segment listed within our triangle, our first triangle. LN is the second segment listed in our second triangle. And finally, we know that PR will be congruent to MN. Also making sure that we list this in our diagram. So QR, LN will list with 2 slashes. And finally, PR will list with 3 slashes. and MN with 3 slashes. Now let's consider example 2. The corresponding parts of 2 congruent triangles are marked on the figure right here. Let's write a congruent statement for the 2 triangles. So one way we can approach this is to recognize that this triangle and this triangle are congruent, but let's list this first triangle by naming it first, simply by any order you choose. I'll say IHG. But before I list the second triangle, I want to make sure that I list the vertex within the second triangle that has the same amount of slashes as I, since I is listed first. Within our first triangle, I has 1 arc. Therefore, I'm going to list K first, since it has 1 arc. Now let's look at the second vertex listed in the first triangle. H is going to be the second vertex in the first triangle. Therefore, the second vertex in the second triangle. Again, this is because angle H for this first triangle has 2 arcs, and angle H within the second triangle has 2 arcs. And by default, we only have 1 more to choose from for triangle KHJ, therefore we'll list it here. But it's always smart to make sure that angle G has the same amount of slashes as angle J, which they do. Therefore, we've listed triangle IHG and triangle KHJ in the correct corresponding order. Finally, let's look at example 3. Here it states that triangle RST is congruent to triangle XYZ. Well, if we want to find the value of n, we need to make sure we can find the angle that corresponds to angle Y. Again, we can look at our congruence statement here. Angle Y is the second vertex listed in our second triangle. So we want to make sure that this angle is congruent to angle S, since angle S is the second vertex listed in the first triangle. Since angle S is congruent to angle Y, I can now write an algebraic statement. Angle S is 50 degrees, and angle Y in terms of n is equal to 2n plus 10. So let's write our equation here. Angle S is equal to 50 degrees, and angle Y in terms of n is equal to 2n plus 10. Now we have a congruent statement, and we can solve for our variable. So let's do some algebra. I'm going to subtract 10 from both sides. I get that 40 is equal to 2n. And then dividing both sides by 2, I get that n is equal to 20. Now that we have familiarized ourselves with terminology used pertaining to congruent triangles and applied those with 3 examples, this concludes our introduction to congruent triangles.
Made with Doodlecast Pro.